graphing y equals a sine of x plus d or y equals a cosine of x plus d. So we're looking at situations where there's an amplitude change maybe, and there's a vertical shift. So let's do these. They're really not that much different. Oh man, in the previous video, I forgot to do the domain and range. I just realized that. Well, if you're watching this because you're watching them all in a row, the domain here is negative infinity to infinity, and the range is negative 2.5 to 2.5. I don't do video editing super well, so I'm not going to edit that back in, but there you go. I'm only thinking about that because the range gets to be a little bit funnier as you put in vertical shifts. So once again, I will start with that. I'm going to start with D. Maybe I'll start by rewriting it slightly. Y equals negative 3 sine of x minus 0 plus 1. Our D value is whatever value is sitting off here at the end. So that's 1. So that means a vertical shift of 1. It's positive, so it's up 1. And the midline is just whatever number D is. So the midline is at y equals 1. Come here, y equals 1, boom, midline. The amplitude, well, A is negative 3. The amplitude then is positive 3. A is negative 3, amplitude is positive 3. So I go up 3 units from the midline, right? This tends to be a part where people get this part right going up. So 1, 2, 3 units up. There is where the top part is. And this is at the y value 4. Y value 4. And then the bottom line, it's not down here at negative 3. It's 3 units down from the midline. So there's 1, 2, 3. It puts the bottom at negative 2, not negative 3. This is negative 2, and 1 is where the midline is. C is equal to 0, so that means the phase shift is 0. There's no shifting left or right, just up. And B is equal to 1. That's the number in front of X. And we said back, poof, all the way back here, if B is 1, then the period is 2 pi. Now, this situation with the phase shift being 0 and the period being 2 pi is a nice special situation because the key points for those are going to be the same. We have the same key points here, and it's because there was no phase shift and there was no period change. So if the period doesn't change from 2 pi and there's no phase shift, the key points are always going to be the same. You always start with your phase shift of 0, and then for this particular scenario, it becomes pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And again, we've talked about how like you can, yes, this simplifies and so does this one, and it doesn't matter how you write it, whatever makes your heart most happy. But those are the same key points as we had before. So I just mark them on the x-axis. Here's 0, pi over 2, pi, 3 pi over 2, and 2 pi. I'm looking at sine. So sine always starts at the midline. So my first x value is 0. I'm starting at the midline. And then because A is negative, we go down first. And then I just ladder step. So I go down at my next x value, hit the bottom, go back up. I'm not putting, it's really tempting to want to put the dot here. It's not, it belongs on that midline. Up to the top and then back down. And that's one period of the function -3 sine x plus 1. The domain on this guy, -infinity to infinity, and the range, the lowest y value is -2, the highest is 5, the range is -2 to 5. This does fit in with the formula that you get up here. I put this in here because I felt like it works. All this says is the bottom part of your range is the midline minus the amplitude, and the top part is the midline plus the amplitude, which is exactly what you're seeing here, right? Plus the amplitude, minus the amplitude. And again, these are guiding lines. They're not really there. They're just there to help guide your drawing. All right, let's do one more here. So rewriting this, y equals 2 cosine of x minus 0 minus 2. We'll start with the vertical shift. It says -2 at the end, so d is -2. So that means that the midline is at y equals -2. I'll come here, boom, -2. A is 2, which means the amplitude is 2. So we go 2 units up and 2 units down to plot the tops and the bottoms. There's one here, and there's one down here. Again, we are in a situation where C is 0, which means that there's no phase shift. The phase shift is just 0, no phase shift. And B is equal to 1, that's just the number in front of X. And if B is 1, we said that the period is 2 pi. And that was from a previous video. Again, these key points are the same. They're the same key points. Because as long as the period is 2 pi and the phase shift is 0, the key points are going to be these guys, the same ones as their basic sine and cosine functions. So once again, I'm going to come in here. Here's 0. Oops, this is the x-axis. 0, pi over 2, pi, 3 pi over 2, 2 pi. We're looking at cosine, so that means we start at top or bottom. Our A value is positive, which means we start at the top. So my choices, again, if you're looking at this as kind of like a grid, right? So like that, the only places where you're going to plot points are on any of these intersection points. That's all you need to do. So we are starting at the top right here, and then we go to our next important x value and we step down to the bottom and then start stepping up again. Right. Once again, super easy to continue this pattern. You could do it forever because it goes on forever. Oh, yep. Ooh, wait, no, I misplaced that first one. 2 units over, 2 units over. There you go. And it would continue out that way. The domain on all of these is -infinity to infinity. For this one, we have the bottom is at -4 and the top is at y equals 0. So this is from -4 to 0 from the range. And that's that. So that's how you deal with a vertical shift. It's not a big deal. In the next video, we're doing phase shifts. No, period changes. We're doing period changes in the next video and then phase shifts after that. Hope that made sense. If you have questions, let me know. Otherwise, I'll see you in another video. Bye.